bones develop following one of two different types of bone development processes. So first of all, bone development can either be called ossification or osteogenesis. And the two main types are intramembranous ossification and endochondral ossification. And the key difference between them is the material that is used as the precursor to forming bone. So let's take a look at intramembranous ossification first. Intramembranous ossification is used to form the flat bones in the body. So for example, the bones in the pelvis and the bones in the skull. It begins during fetal development, so it begins prior to the birth of a baby, and it continues into adolescence. And the key thing is that compact and spongy bone forms from something called mesenchymal connective tissue. And this mesenchymal connective tissue is undifferentiated, meaning it's not cartilage, it's not fibrous connective tissue. It's kind of a precursor to different types of connective tissue. And so you can think of the mesenchymal tissue as being kind of like a pattern or laying down the framework for where the bone is going to be. So let's take a look at some of the steps of intramembranous ossification. So in step 1, the mesenchymal cells group together into clusters and form an ossification center. All right, so you've got these mesenchymal cells, which are these undifferentiated connective tissue cells. So it's a type of stem cell. And so it starts to kind of put down the framework for where the bone is going to be. Those mesenchymal cells then start to secrete osteoid, and osteoid is just the extracellular matrix, or what will become the extracellular matrix of the bone. That osteoid, or extracellular matrix, traps the osteoblasts, causing them to become osteocytes. The trabecular matrix forms and the periosteum forms around the edges, around the surface of the bones. And then the compact bone develops superficial to the trabecular bone, and the blood vessels that originally invaded the spaces of the trabeculae become the red marrow. And remember, red marrow is where red blood cells and white blood cells are produced. All right, so in kind of in summary, so you start with mesenchymal cells that produce an ossification center. So they're laying down this kind of undifferentiated tissue as a framework. Then you have osteoblasts that start secreting the extracellular matrix, and the osteoblasts become known as osteocytes once they have secreted matrix all the way around them. The trabecular bone forms, so the spongy bone forms first, and then compact bone forms on each surface. And the blood vessels that invaded the spaces of the trabeculae become the red bone marrow in the spaces of the spongy bone. Now, endochondral ossification, it also starts out as mesenchymal tissue, but instead of mesenchymal tissue being replaced directly by bone, it first becomes cartilage and then it gets replaced by bone. So endochondral ossification forms most of the bones in the body. So intramembranous ossification made just the flat bones. Endochondral ossification is for everything else. It begins during fetal development, so it starts before a baby is born, and it continues until someone reaches their full-grown height. So let's take a look at some of the steps of endochondral ossification. So in the first step, mesenchymal cells differentiate into chondrocytes. So remember, mesenchymal cells are undifferentiated stem cells that are associated with connective tissue. And a chondrocyte is just a cell associated with cartilage. So these chondrocytes start forming the matrix of cartilage, and it sets up a cartilaginous template of where the bone is going to be. So prior to it looking like a bone, it still looks kind of like a bone, but it's made out of cartilage instead of the hard osseous tissue. So a structure called the perichondrium, forms on the surface, and this perichondrium is similar to the periosteum. All right, in the next step, capillaries start to penetrate into the cartilage framework, and the perichondrium transforms into the periosteum. This is now known as the primary ossification center, where bone tissue is going to start breaking down, the cartilage is going to start being replaced by bone tissue. So the diaphysis of a long bone, in this example, forms first. In the next step, capillaries invade the epiphyses, which are the enlarged ends on either end of the diaphysis. And so this is now going to be a secondary ossification center. And we can't see the other epiphysis on this picture here because it's been cut off, but this other epiphysis would also get blood vessels coming to it, forming a secondary ossification center. And these secondary and primary ossification centers are just areas where the cartilage is starting to be replaced by hard, bony osseous tissue. Towards the end, all of the cartilage is replaced by osseous tissue, so all the cartilage is now bone. But there is some cartilage that gets left behind. So some of that cartilage are the articular cartilage is the articular cartilage that covers the end of a bone to help protect it in a joint. And then the epiphyseal plate is this kind of boundary or this divider between the diaphysis and the epiphysis. And this plate is involved in allowing this bone to continue growing lengthwise throughout life. So as someone grows up, their bones grow with them and get bigger, and it can do so because of this epiphyseal plate. So if we take a look at this epiphyseal plate here, so these are x-rays, and in the x-ray here on the left, you can really clearly see the epiphyseal plate. So this is the diaphysis of the femur, and this is the epiphysis of the femur. This is the epiphysis of the tibia, and this is the diaphysis of the tibia, and then you've got your fibula over here. So this cartilage here is a growth plate. So what happens is as your bones grow longer, this cartilage reproduces itself to make more cartilage, and then that cartilage gets, at least on the surface of the cartilage, it gets ossified and turned into bone. So you can kind of see over here, you've got your epiphyseal plate, which is your cartilage here. And so this cartilage keeps reproducing to produce more cartilage. And then on the surface of the cartilage, it becomes ossified and becomes bone. Now, when you reach your full-grown height, the epiphyseal plate will completely ossify, and it becomes known as the epiphyseal line, which is, it kind of looks almost like a scar. So you can see here on the right, you can still see what used to be the epiphyseal plate, but you'll notice that it's not a clear separation between the epiphysis and the diaphysis anymore. And that's because this cartilage has now ossified. And once this epiphyseal line has formed, the bone is no longer able to grow. Now, in addition to growing long ways, our bones can also grow in diameter, so the thickness of the bone. And so as you get older, your bones also get wider. And in doing so, you have new bone tissue that is deposited on the outside, and it's deposited by our osteoblasts. So remember, osteoblasts make new bone tissue. But if we didn't kind of come in here and hollow out the medullary cavity a bit, our bones would get really, really thick, but really thick in a bad way. So the bones would get so thick that they would be so heavy that we wouldn't be able to move them around very easily. It would also limit how much of that yellow marrow we could store in the medullary cavity. So as new bony tissue is being laid on the superficial surface of the bone, the older bone matrix that is lining the medullary cavity gets broken down by osteoclasts. So the bone overall grows wider, but the width of the actual compact bone doesn't change kind of proportionately. It just keeps getting, as the outside gets bigger, the inside medullary cavity also gets bigger. Now, in addition to growing taller and growing wider, our bones can also change in their shape based on how we use them. So even throughout adulthood, after you are full grown, your bones are still going to be changing in shape. And so your bones respond to stress. So for example, this is a femur bone here. And so you can see the stress associated with activities such as walking or jumping or working out in some way. So the bone has a little bit of give to it, and that's due to the collagen giving it a little bit of flexibility, but your bones want to make sure that they're strong enough to withstand the type of stress that they're going to be subjected to on a regular basis. So for example, if you were to, let's say your primary way of exercising is to walk a mile a day. Your bones are going to adapt to the stresses put on them by walking. Now, if you were to switch from walking to riding a bike as your form of exercise, your bones over time would adjust to the different stresses associated with riding a bicycle. And it's just because your bones are being used in different ways with those different types of exercise. Also, if you're injured, this remodeling can help to heal bones and kind of help to reshape the bone back to what it was before it was injured. Additionally, about 5 to 10% of our bones are replaced or remodeled every year, and this is just for basic upkeep. So as a part of a tissue gets old, it can be broken down and replaced by newer tissue.